Okay, in networking, basically computer networking, what we are concerning here is connecting two or more computers together, right? How can we connect two or more computers together using wired or wireless media? Basically, that is a network. So yeah, using either wired media. So wired media can be, so I'm just revising from the theories. Wired media can be fiber optics. So that is basically called guided media. So it can be fiber optic or coaxial cable, which has a single axis, and it can even be a twisted pair. That means a pair of cables which are twisted. Twisted means wrapped together. The reason for wrapping is this. The reason for wrapping them together is, so you know, when a conductor transport electricity, there will be a magnetic field around that, right? When there's a conductor which is sending and receiving electric signal, there will be a magnetic field. So this magnetic field will act as a resistance to the media, right? When there's a magnetic field, it is acting as a resistance to the media, so it will slow down and drop the data rate. So that issue is there. When there's a straight line, when there's a magnetic field, when signal pass through that straight line, due to the resistance as well as the magnetic field, there is a higher tendency to drop the signal or reduce the quality of the signal. Maybe noise can be added. So that is there. Therefore, basically in here, the two cables are twisted together, twisted around. The reason is, when one cable is twisted, there is a magnetic field generated in a certain direction. The other cable is twisted oppositely, there will be opposite magnetic field. So what will happen? The direct magnetic field and opposite magnetic field will cut down, right? Therefore, the effect of the magnetic field will be reduced. So due to that, right? Due to that, the resistance will be there. Resistance will be reduced. So that is the reason for the twisted pair. But you don't have such thing for fiber optics, because fiber optics transport light. So it's really less hassles. This is an example for fiber optic, right? You can see this is an example of fiber optic. Okay, so I hope that this part is clear to you, right?
Yes, sir.
Okay, so you know about this attenuation, signal strength and all, right?
Yes, sir.
Okay, then, so let's do the, let's learn the protocol part, right? So it can be done. Here you can see the wireless media also. Just these are the wireless technologies. So Wi-Fi, Zigbee, then microwaves, Bluetooth, these are wireless unguided media. So what we are going to do is, actually the media is the main concern in connecting to the network. Media is one of the main concerns. And the other concern is, you know, the devices. So devices, media. Then for network, what else you need? Devices, media. You need devices, network devices, which are capable of networking. And also you need not just the devices, you need media devices. Then what else? Hello?
Communication modes.
Communication
Modes.
modes means, what is communication mode?
So like simplex, duplex.
So network communication can be established either simplex, duplex, that doesn't matter. So, but that is not a Anyway, so all these things together, we can call them protocols.
Okay.
Okay, all these things together, you can call them protocols. I think that is the better word, right? So rather than communication modes, protocol is a way of communication, how it happens, how the physical communication happen, how the logical communication happen. So how data transported, all these things, protocol. Okay, you need media, devices, and way of communication, protocol, and also software capable of delivering services. The software also work according to the protocols, and the components, devices are also working according to the protocols. So important things are the media, either it's wired or wireless, then the devices and the protocol. So those are the three things essential for communication. So what are the purposes of networking? I'm just revising. I'm just asking you the questions whether to check whether you know this or not. So can you tell me, yes, what are the purposes of networking?
Moving the data from,
yes,
moving the data source to the destination.
moving data from source to destination. Okay. Generally, so we can refer that as communication, right?
Yes.
We can refer that as communication. Okay. So what else? Is it only communication or is there anything else? Is it only communication or is there anything else?
So,
Purposes of networking. Why we need networks? Yes.
so transfer files.
Transfer files. So be generic, right? So be generic. So these are like points, but be generic. Communication is one main thing. The second thing is sharing resources, right? That is the second thing, sharing resources. That resource can be a file, resource can be a printer, resource can be a scanner, resource can be internet. So you can write those in the point format. When you are answering the questions, you can say internet sharing, file sharing, database sharing, application sharing, storage, shared storages, then shared storages. Likewise, you can write many things. Sharing devices like printers, scanners, internet connection sharing, then user authentication, centralized user sharing, or the user authentication, active directories. All these are coming under. All these are coming under resource sharing. So generically, generic or the general idea is resource sharing. Okay, there are two requirements. There are two things that network does. So the one is resource sharing, the second one is communication. So those are the two things that network does, right? So under that, you can write whatever you mentioned. Sharing files, sending data from source to the destination. Yes, all these things you can write, but those are not generic. Under that, you can explain, yes, these are the points. So what you're telling is the point format, right? So, but generally get an idea. So because it is easy to get a general idea and explore, that is called like, it's kind of brainstorming. You generally have an idea. Okay, let's say, for an example, you're thinking about a meal. So why we need meal? Because we need nutrition, we need energy. That is the general idea. Then you can say, I need rice, I need the kottu, I need something, I need sugar, I need this, likewise. So because like mostly I have seen most of the A-level students, they have scattered knowledge, but they don't know why really these things are. That is one of the main problems that I see in the A-level ICT, not just in the A-level ICT, other students also. They know the points, they know how to write the examination. That is true, but they don't have proper idea why this is happening. So just have the idea, then explore further. When you have the idea, you don't want to even by heart these things. Because generally when it comes to your head, okay, resource sharing and communication. Communication, you can write down all these things, send in files, send in messages, send in chats, send in, take in calls, network calls, network software, network related chat. So like, all these are coming. Then resource sharing now, file sharing, folder sharing, file sharing, software sharing, database sharing, printer sharing, faxing, and maybe user share databases, all these things. Okay. That is general idea. Okay, now few things. So now network media, quickly revised. Then what are the things done using the network. So can you tell me the network impairments? What are the network impairments? Yes, network impairments. Hello? Can you hear me?
So I couldn't hear the question.
Okay. I asked, what are the network impairments? Can you hear me now? Am I audible? Hello? Varun? I cannot hear you, Pute. Varun?
Yes, sir.
Okay. Right. Yes. So I asked a similar question, which is related to this. Right. So what are the network impairments? So that is also related to the incident that happened. So what are the network impairments? What is network impairment?
So no idea.
No idea. Okay, you said that you heard of like attenuation, distortion, noise. Have you heard of?
Yes, sir.
Those are called network impairment. That is why I said always go from the general. Don't go the point by point. So because like this in the A level other subjects, yes, other subject, most of the subject there is a tube to be filled. In under that you are filling the tube point by point. That is true. So I know how we learn A level like this. We were just filling the tube point by point. But here in ICT, so don't learn like that. Doesn't matter. But the thing is, don't learn like that. Learn with the idea, right? Learn with the idea. Always check the general idea and dig into it. So network impairment are the issues affecting the network. Issues affecting the network quality or the network services. So this is the word, right? Network impairment. You can see. This is the wording, right? Network impairments. So then, so under the network impairments, that is where you are learning about certain things here. It can be attenuation, distortion, or noise. But impairment can happen due to attenuation, distortion, and noise. What is attenuation? What is attenuation? Yes?
Something like yeah,
Something like?
interruption.
So distortion. Distortion. No idea. Okay, then what is noise? Noise?
Something like sound.
Yeah, some like unplanned sound. So you can see even when we are doing classes, sometimes noise appears because some kids are shouting, sometimes noise of wind, noise of magnetic fields, maybe So certain things. Noises means whatever appearing other than the intended signal, other than the expected signal, any other signals affecting the particular signal are called noise. Any channel, there's a noise, right? So even this channel, when you are conducting classes, you can hear some voices, additional things, wind sound, maybe lagging sounds, call sounds, or the ringtones, various wind sound of the wind, maybe birds, animals, likewise. You can hear some sounds. That is natural, right? So that is naturally there. But the thing is, we need to minimize that. We cannot actually keep the noise in the channel, keep big noise in the channel. No, noise channel like a noise if there is a more noise in the channel, the signal will not be clear. The distortion means the shape of the signal, right? The shape of the signal or the original signal is somehow altered. That is called distortion. Right? Attenuation means it is basically what is happening when you go to a distance. So if you are close by, so let's say we are physically in a class and you are nearby me, you can hear my voice very well. But let's say you are 100 meters away from me and we are not using microphone, then what will happen to my voice level? Can you hear the same level, or they will be lower than the expected level?
So lower than the expected level.
Lower than. So this is called attenuation, right? The signal initially at the source, what you say source, that is the signal sender's place or the source, the signal strength is high, but when it goes to the far away place like distance, the signal will be lower. You can see here the digital signal, analog signal, both will attenuate. So may I know what is analog, what is digital? What is analog, what is digital? Those are also needed because before the calculation, we need to know what is exactly there.
So the signal types.
Yes, signal type. Yes. So what is analog signal type? What is digital signal type? Yes. Analog and digital type. In analog, okay, remember these things, right? In analog, signal has continuous levels. Analog signal has continuous levels. Continuous levels means, so between a given range, signal can take any value. Right? Between a given range, a signal can take any value. We call that analog. Between a given range, a signal can take any value. We call that analog. Right? Between a given range, if a signal can get specific values in between a given range, right? If signal can get specific value, we call digital. Right? You can see 1, 0, specifically 1, 0 only. No halves, no partial, no quarters, no point, no decimals. That's especially the particular part. Right? So that is digital, specifically certain values. Then a values with specifically certain values. But if it is, it's like this, right? You can see these are specifically given values. No intermediate values, specifically given values. But the thing is, sometimes in some like signals, the original signals, so you can get range of values of weight of a person, height of a person can be vary, right? Weight of a person can be vary, height of a person can be vary. Maybe the voice range that we can hear, that you and me can hear, the voice range is vary, right? So those things are variable, and therefore those are called the variables. Those are called analog. But if it is not vary, if it is like specific levels, so for example, a signal can have only 5 voltage, 0 voltage, only two levels. That is digital. A signal can have 0 volt, 3 volt, 5 volt only 3 levels. That is also digital. But if it can be any value within a given range, then any value between a given range, then you can say it is. If it is any value between a given range, we call analog. I hope you understood that, right?
Yes, sir.
Okay. Now, so what is attenuation then? Lowering of the signal power with the distance. So please remember these things. Lowering of the signal power with the distance is called attenuation. Distortion. Distortion. Yes. Come on. So distortion is basically, okay. So let's say picture is a distorted. A picture is distorted. Picture, the existing picture, you can see it is stretched, dragged, swapped, like this is called distortion. In signal, so this is called distortion. The original image is square, but this is distorted. The shape of the signal has changed. Right? This is the original input, and you can see the distortion. This is distorted. Similarly, distortion can happen to the signals. So signal distortion is when there is original signal. Okay, you see here. So this is original signal. Right? This is the original input signal, but place to place, there can be varies. There can be cutoffs, distortions. Here, the original and the distorted. The original and the distorted. So that can be due to delay. Right? That can be due to delay. Then so so this has happened to us during the class. I was talking to you and you said you couldn't hear properly. There was a lag in. Why? What is the reason?
Distortion.
Distortion. Exactly. That is delay distortion. So the signal is delayed, so you can hear something like that. So likewise, it's like you can hear something like this, right? So likewise, the lagging happens. When lagging happens, called delay distortion. Anyway, distortion can happen due to several reasons. Maybe a signal failure, maybe a lagging of the network, maybe due to clipping or cut off the higher levels and lower levels, maybe mixing with some other signal due to noise. So distortion can happen. Noise is anyway unexpected signals present in the communication environment. In the communication environment, if there are any unexpected signals present, that is called, these unexpected signals or unexpected signal present are called what? Noise. Okay, now you have clear idea about these basic properties. We know the digital analog signals. Okay, I hope these things are clear. Amplitude, frequency, wavelength, and phase. Right, I'm not going to discuss that. There is anyway belongs to theory part, but I think that you have idea about this. If not, I can explain why I explain this. Like even I explain these things. Why? The reason is I understood that you have some gaps between theory that you have learned. That is why I was explaining this again, right? Here, delay, distortion due to latency, noise, attenuation. Okay, then digital analog signals. Okay, now it's high time to learn about the protocols. So what are the protocols? So what's the difference between protocol and topology? Yes, here topologies are also there, the protocols are also there. So what's the difference between topology and protocol?
So protocols are the set of rules and regulations for a networking.
Correct. Okay. The topologies. Protocols are set of rules and regulations, or set of rules and conventions that explain right, that explains that helps proper communication. Yes.
So, but I don't know about topologies.
Topology. Haven't you discussed this? Not yet.
No, sir. We just started the theory parts.
Not with the theory part yet. Okay. Then the topology is actually the arrangement. Please make a point. So you can just put a point and write down. The topology is arrangement of the network. So that can be a physical arrangement, that can be a logical arrangement. Physical arrangement means how computers are connected using wires or wireless media. How computers are connected is called physical arrangement. So the physical arrangement can be, the physical arrangement is different from one place to another place. So maybe geographically there can be differences. Location wise can be differences. So technology wise there can be differences of the physical arrangement. based on the usage. There are different arrangements. So there we actually, these are very basics. But so if you want, I can explain this very quickly.
Okay, sir.
Okay. About the arrangements, we'll do the calculation part, but you need to have an idea about the physical things. That's why I'm okay. So this is these are arrangements, modulation. Okay, here we are. So this is one arrangement. You can call this mesh topology. Here actually computers are connected to each other computer individually using a dedicated line. Right? Using a dedicated line, computers are here. You have A, B, C, D, E, 5 computers. You can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dedicated lines connected. Right? Connected this. So what is the idea? Why you need this number of lines in networking? This number of connections in mesh topology? What do you think? What's the reason? Do we actually need this number of? So why? Actually, having 2 lines enough, but here it's having more lines.
So all the networks are connected. All the computers are connected to each other.
Yeah, all the computers are having dedicated lines. Yeah. Okay. That is true. All the computers are having dedicated lines. That is true. So what is the advantage of having such networks? These networks are called fault tolerance networks. Right? These networks are called fault tolerance network. That means these networks are so strong, difficult to break. So networks are so strong and difficult to break. So the reason is, okay, let's say if you break this line, still there are other lines too. This computer can, let's say this line is not there. Still this computer can connect to this computer and then connect to this computer. It has access. This way it has some kind of access. So these are basically using military networks, forces, because they need strong forces, or the military network, they need strong kind of network, because they are the ones affected mostly in this security issues. When there is an attack or when there is something wrong, right? So then actually, especially in case of terrorist attack, the first place to attack is the network. First place to break down is the network. Therefore, they need another way of connecting. Let's say army camps. These camps are connected to each other using mesh topology. Then they can extend, they can ask for help easily. When there's something going on, they can ask for help. Right? So that is this fault tolerance network. So that is this mesh network. Actually, you can calculate the number of lines needed. If there are 6 pieces, there will be 15. If there are 8 pieces, there will be 28 lines. How can we calculate? Right? Here, 2 pieces, only 1 line is enough. Then these are triangular numbers, right? 3 pieces, 1 and 2 more needed, because 3 pieces means like this: 1, 2, 3 pieces. Then how many lines you need? 1 line, 2 line, and 3 lines needed. Let's say another PC comes, the 4th PC. Due to the 4th introduction of this PC, another 3 lines will be introduced. 1, 2, 3 altogether now, 6 lines. Then 5 PCs, 6 plus 4, 10 lines. 6 PCs, 10 plus 5, 15 lines. 7 PCs, there will be 21 lines, and 8 PCs, 28 lines. So if you write an equation, it is n into n minus 1 divided by 2. That is how you calculate the number of lines required to connect mesh topology. Right? The advantage of mesh topology is very hard to break, false tolerance, lot of lines connected, So it is a better way of having strong network, a better way of having strong network. That is called mesh topology. Okay. Are you clear on this?
Yes, sir.
Okay. Then there are partial connected mesh. That means all the lines are not there, but some lines are there. So it's called partial connected mesh topology. And not only that, there are some other topologies. You can say bus topology, ring topology. Let me show that as well. These are also topologies. Okay, see here. So physical topologies, bus topology. Right, bus topology is where the network is connected to a central baseline. So see here, just study only the baseline. So I'll show you an image of bus topology. So this is it. So there is a central baseline or the central line in the bus topology, and the computers are connected to this main line. There is a central line, and all the computers, servers, printers, whatever the network devices, name it, are connected to this central line. So what are the advantages? What are the disadvantages? So what do you think? Just think. So what are the advantages? What are the disadvantages?
So all the computers will be affected if the main terminal.
Yeah, all the computers are connected to the main line. So what will happen?
So if there are breakdown, all the computers.
Yeah, if there is a breakdown of the main line, every single computer and the computing device will be affected. Right? Every single computer or computing device will be affected in case of the main line failure. Main line failure will affect all. And to connect a new computer, you have to disconnect the main line, disconnect the network. Right? To connect a new computer, you have to disconnect the main line. Also, right? Also, if you need to disconnect a computer, still you need to disconnect the main lines, like, you know, power lines and the tap lines or the water lines. So these power lines or the water lines are actually working this way. Why? Because let's say a nearby house need the power maintenance. So what will happen if there is a power maintenance in nearby house by CEB, Central Electricity Board? Yes. If there is a power issue in the nearby house, what CEB will do?
So the power supply for the all area will be disconnected.
Yeah, the power supply for the all area will be affected. So that is there in this. So similarly, remember, similarly, if there is a water line maintenance, and if there is like maintenance, like cutting trees, the entire region, entire area, all the computers are affected. That is not fair, but it will happen. This is very simple method. This is a very simple method to give power to new computer. Just connect it. These are called T connectors. If you want to give power to a new place, just connect the T connector, give the power. But during the connection time, the network will drop. Here also add in a new one, remove a new one. So you have to remove the T connector and just connect the line, and that will also affect the network. So this is not extensible. This is not very good extensible network. This is extensible, but the thing is having a lot of interruptions. Having a lot of interruptions, disconnections, connections, lot of interruptions. Therefore, this is not very good network, but it is very simple design, right? Everyone can understand what's going on here, right? Anyone by looking at the picture can understand what should do. Anyone can connect a new line easily, right? Anyone can connect a new line easily. Therefore, this is a simple design, easy to implement, fast to implement, less number of wires. You need less wire in length, and a lot of advantages are there. For true, yes, but the thing is, there are main disadvantages also. The main disadvantages are interruptions. Adding, removing new computers will definitely interrupt. And not just that, then if there's a maintenance, it will interrupt. So that is the bus network. I hope this is clear to you. Right? Since this is a revision class, I'm not giving notes, but if you need notes, please tell me, right? Do you need notes on this, or what do you think? Can you watch the videos and
I need them. No.
no need, right?
Yes.
But the important points I expect you to write down somewhere, right? After watching,
Okay.
you can watch this again if you want. And the important point, please write somewhere, because otherwise you will forget the theory part. Okay, next ring bus topology. Then there are some other topologies. So one is ring topology. So let's see how ring topology works. So what do you think? So is in the bus topology, so can many parties send and receive signals same time? So what you said, like, is it duplex? Is it duplex kind of network? Is it like supporting multiple communications? Or only one party can send and receive signals? What do you think in the bus topology? Can many parties communicate simultaneously, or only one party can communicate?
So one party.
No, it's many parties, right? Here, this can communicate with this one easily. Meanwhile, this can communicate with this one. And also, if this person can communicate with this one also. No issues, right?
Okay.
Because these are independent connections. But the thing is, so when this try to communicate with this one, maybe this will be busy. Right? Can communicate simultaneously. It is possible to communicate, but there can be interruptions. This is not totally interruption-free topology. This has interruptions, but the thing is multiple parties can communicate. But unlike this, ring topology, multiple parties cannot communicate. Bus topology, multiple parties can communicate, but collisions, the problems will happen. Collisions may occur. Here in the ring topology, multiple parties cannot communicate. So what's the reason why multiple parties cannot communicate? So what do you think the reason is? Because
the data are flow in a circuit.
yes, you know ring topology?
Sir?
Do you know ring topology?
No, sir. I just saw the diagram.
You just thought, right? Okay. The idea is the data circulating in a single side, like clockwise or anti-clockwise way. Data basically circulate in single side. Therefore, the computers must wait. Computers cannot communicate ad hoc manner. It must wait for the communication. There's something called token. This token is, so when somebody want to send data, in this network, they must raise the hand and obtain the token. This token is actually the authenticator, or token is the initiator, right? That that is the initiator. This token will tell, okay, you are ready to communicate. Okay, let's say this is A. A want to communicate. A grab the token. After grabbing the token, A will attach A's data. And A will print the address. This is where the calculations comes. Next, we need to learn what are these addresses and all, and how the address calculation happening. But before that, we need to know the theory part. No, that's why I'm just doing. Then the data is attached to the token and sent to the, let's say this is sent to D. The address is attached and sent to the, then this will be moving. The others know that token is not free because it's going with data. So others must wait to communicate. Let's say this reached D. So actually everybody reaches the message. B also read that, but B knows it is not for them. So B will ignore. C will also receive the message. C knows that it's not to him. C will also ignore. It will go to D. D knows that it is to me. D will detach the data and read the message. And sometimes D will attach another thing saying I received the message. That is called acknowledgement. It's like delivery report, acknowledgement, or the feedback. So D will attach the feedback and D will send the feedback back to A. So then the communication cycle over. So as a result, what will happen in the ring topology? Will it be faster or slower?
Slow.
Yeah, it is slower. The reason?
So because the data for the D is transferred from D and to C, so data
Yes.
flow will be very slow.
It need to wait, right? Always. Yes, need to wait. So because like multiple parties cannot communicate same time. Right? Multiple parties cannot communicate same time. So it needs to wait. Need to wait and see. And not just that. So when one party is ending the once when the acknowledgement is not received, still the other parties need to wait. And it need to wait until this go the cycle and counts. Move to the cycle and counts. It has to wait. So waiting time is more. But what about the collisions? What about the collisions? Yes. What about the collisions? Hello?
Sir?
So what about the collisions? Collisions means the problems, crashes.
So if breakdown in one computer can break down the entire network.
No. So that is true. Breakdown in the network can collapse the entire network. Breakdown in the line can collapse the entire network. That is okay. I'm asking about message collisions. Message collisions means so in the bus topology, multiple parties could send instructions. Sorry, multiple parties could communicate in the bus topology, but here only single party is communicating. Multiple parties are not communicating. Therefore, there will not be any collisions. Understood? Because
Yes.
multiple parties are not doing. So for an example, let's say I'm doing multiple classes this time. So same time I have allocated to you and I'm doing multiple classes, then there will be collisions. I can listen to you sometimes I will not be able to listen to you. Likewise, there will be collisions. But if I'm doing only your class, then there will be no collisions, right? But the thing is, it will slow down me. Why? I can do only one class at a time. I hope this is clear to you, right?
Yes, sir.
The problems, as you said, yes. The disadvantages is the breakdown of the line can affect or entire network. Adding, removing computers will affect the entire network. Advantages, the quality is high, less traffic and less collisions. So that is the advantage. Okay, the third is star topology. This is more common topology. In LANs, local area networks, this topology is more common. I hope you have experienced this kind of networks, maybe in your computer lab, in your school, right? Maybe in your school or maybe in a company, organization. So this is the star topology. So it looks like star, but don't think that everything arranged like star is a star, right? Sometimes this can be there in your head. Sometimes there's a network, let's say network is arranged like this. 3 computers are there. Then there will be lines like this. And there's a switch here connecting all 3. So what is this topology? The pink color one. Is it bus topology or star topology or ring topology? What is that?
Star topology.
Yeah, that is star topology. That is why I said, don't look at the shape. Don't look at how it looks. Think about how the connection happens. Right? Sometimes bus can be arranged this way. Sometimes bus can be arranged this way. But there is a missing place. Missing place means here. Maybe here the network portion is not there. It's not a loop. Ring ekak name. It's not a loop. Here the computers are connected. One computer here. Say one computer is connected to here. Another one here. Another one here. Is it ring topology or bus topology?
Bus topology.
Bus topology. Why? Because this is not going to be terminated. This is going to be terminated there. This is not a continuous loop. This is bus topology. But when you look at this, you can feel this as a ring. It is not. Therefore, be careful. When questions are given in the paper, see about the arrangement, how it is connected, not how it is physically looks like. Okay. So what do you think about the star topology? Any advantages, any disadvantages as you see the arrangement here? Yes, anything? Any advantages, disadvantages?
So mainly all the computers are connected to a switch or a hub.
Yeah, all the computers are connected to switch or hub. Yes, but that is not an advantage, or that is not a disadvantage too. Yes. So I need advantages. Huh?
So if there is a breakdown, the other computers won't be affected. There is a breakdown in one
Yeah,
computer.
if there's a breakdown of one computer, others won't be affected, independent, right? So that is advantage. That is advantage because other computers won't be affected, right? Other computers won't be affected. So that is definitely, right? Definitely that is an advantage. It's independent. The computers won't be affected. So it is definite advantage. Anything else? Yes, anything else?
So there is no interruption in networks.
There is no
Interaction.
interaction means what do you mean by
So
that?
like in ring topology, there won't be a time delay to transfer data.
Yeah, there will not. So all the parties can transfer. All the parties can transfer data same time, right? All the parties can transfer data same time. So, right, all the parties can transfer data at same time. Therefore, there will not be any delays. This is faster. No delays means faster. That is one thing. Another thing is then another thing is this is like not affecting. So the other computers, once it is breakdown, it will not be affected. That is another advantage. But the cable length, what do you think about the cable length? Is it low or is it high? The cable length?
So low.
So each of the computer need a dedicated cable. So there will be more cabling length, right? There will be more cabling length as each of this what do you call, each of this computer, right? Each of this computer, it needs a dedicated connection. There will be more cable length. Okay. Right, these are the things. Okay, let's go to the next one. The last topology that we are going to learn today is the tree topology. This is actually how internet works. Right? Tree is actually mixture of both bus and star. Tree base is bus. Base to tree topology is bus. But it will be expanded into the branches using star topology here, tree topology, and it will be expanded to branches using this star topology. That is the way, right? So you can see here the bus topology main line is connected. This is how the internet is delivered. So there is something called CMIEEE, Southeast Asia, Middle East, Western Europe. So that CMIEEE cable is connecting continents and subcontinents. You can see this is like a bus topology, and to this our ISPs are connected, and how ISPs, internet service providers, are connected is like star topology. So this is the working model of, this is called tree topology. So it has both advantages and disadvantages of, it has advantages, disadvantages, both advantages and disadvantages of tree topology, star topology and bus topology. Okay. Then okay, this part is, I'll if you want, I'll share the note. And there are logical topologies too. Logical topologies means how things are, how these are communicating. These are there in your, these are also there in your syllabus. The ring work, we have already discussed how ring works. Actually, how ring connected we saw. How ring work is called logical ring topology. Right? Ring works according to a token. A token passing happen, a free token will be taken, and that is basically data is attached to the token and sent around, and that is ring topology. Then there are some other topologies called Aloha, slotted Aloha, CSMS CD, CSMS CA. So these are also logical topologies available. Let's go through these things very quickly. Right? So then actually this part is over. That is why I'm trying to finish this. Because then next day we can discuss about the totally calculation parts related to the addressing and all. Right? That can be done. I can hear some noise, I think. Okay, pure Aloha. Right? So let's learn about this pure Aloha topology. Pure Aloha means any node can start transmitting anytime. When I want to transmit, I can start transmitting. That is called pure Aloha. Then if two or more try to transmit the same time, there can be collisions. Collisions means the messages can be crashed. Okay, let's say I'm talking to you, same time somebody else is also talking to me. So anyone can talk anytime. It's like a common meeting. Anyone can talk anytime. It's like a not a conference. It's like a common meeting room. Everyone is chatting. Basically, let's think about lunchroom. Everyone is chatting. Anyone can talk anytime, so collisions may occur. So no control at all. Slotted Aloha means everyone has a time to talk. Right? In slotted Aloha, can you hear me?
Yes, sir.
Yeah. In slotted Aloha, everyone is given a particular time slot to talk. Right? There can be full collisions. Full collisions means, okay, let's say I'm given times like this. Okay, first minute. Now let's say A, B, C, and D are there. I'm telling first minute, now start. Now A started communication, no collisions. In the second minute, I'm telling, no, now second minute, start. Now B, C both starts. Then a collision can occur. Right? Because there are given slots, but in these given slots, two people can start talking same time. Given slots. So pure Aloha is like tuk-tuks, 3 wheels. Anytime higher comes, they go. But slotted Aloha, it's like buses. They have a turn. But there can be turn collision. Same turn, two buses. If two buses go, there will be a collision. Right? Both are ways of multiple access. But this is not a multiple access, right? Ring topology. It is a single access. Ring topology is a only single party. But slotted Aloha, pure Aloha, multiple parties can communicate. Then CSMA. CSMA is basically sense in the channel. It's like intelligent meeting. Maybe morning meeting in your school. It's an intelligent meeting. Morning meeting in your school. That means everyone sees for an opportunity. When there's an opportunity, only people will talk. They will sense the main line. They will sense the main line, and when there's an opportunity only, they started talking. හැමෝම බලන් ඉන්නවා ඔක්කොම බලනවා free නම් තමයි කතා කරන්නේ. principal ට අපි කියලා කතා කරන්නේ. When we want to talk to the principal, අපි බලනවා sir free ද? So are you free on this time? Can I talk? So that is CSMA. Actually, that can happen two ways. CSMA can also happen. CSMA means carrier sense multiple access. That can also happen two ways. Carrier sense multiple access, collision avoidance, and collision detection. The principal room nearby the principal's rooms, lot of students are hanging out. Let's say principal is not that much arrogant person. He's a very good, kind person, kind-hearted person. So everyone loves him. Let's think like that, right? Let's think like that. And since everyone loves principal, so he's basically in his room, and people are queuing, or people are in the door, at the door, or students are at the door to talk to him. Students are at the door to talk to the principal. So when somebody leaves, everyone is trying to, can I talk? Likewise, that is carrier sense multiple access. Actually, you are seeing what is happening in the principal room, but you try to come together. That can cause clashes. Excuse me, sir. Two people can raise hands saying, I have a question. So that is CSMA ZD. So understand this very well, right? Otherwise, this is a bit confusing. Understand with the examples. Aloha it's like a hassle. Everyone is trying to communicate. But slaughtered aloha, some better thing, because everyone is given a time at least. It's like aloha is like aloha is actually like earlier fuel queues. Everyone was fighting. Later fuel queues like slaughtered aloha. The date is given according to the number, slots are given slaughtered aloha. CSMA is like it's like QR code. So everyone will check for the availability and then sense the line and go accordingly. It's like the QR code system. And CSMA CA is like, that is exclusively, you can book a time prior to this and then go. Only you will be there. That means you can, prior to the communication, you can reserve your slot. You wait random time and reserve your slot. Here you are not waiting random time. You are just sensing the line. If line is free, you start. You are looking at the queue. If queue is free, you go to the queue. You are looking at the queue. If queue is free, you will go to the queue. But there can be jams. Two parties can go together and you have to solve that. That is called jamming. Two signals collide. That is called jamming. Then you need to solve that problem. But in CSMA-CA, it's like you sense the line, you see the availability, shed is free. Then you are checking whether my turn, is it my turn? If it is your turn only, you will go. Otherwise, you won't even take fuel. So this is slow, but quality. This is faster than this. But this is also okay. Nowadays, Ethernet, most of the local area networks use CSMA. These are the logical ways of communicating. Are you clear on this?
Yes, sir.
Okay. Right. The remaining part, then I'll be doing another day. Please let me know if you have any free day. I'll arrange another session. Right?
So by tomorrow at the same time, like
tomorrow, same time, not sure. I'll let you know in morning, right?
Okay.
Okay.